back everyone. Today we are discussing about spectrum. It's a very interesting topic about spectrum. When sunlight is passed through a prism, splitting of light happens. That is, light split into what? 7 different colors. And that process of splitting of light when it passes through a prism is called as dispersion. Dispersion. Splitting of light into 7 colors when light passes through a prism is called as dispersion. And the bands that we obtain, okay, the colors of the bands that we obtain is called as spectrum. That is, okay, consider this is a prism. When sunlight is passed through a prism, light bends. That is, we studied about refraction, isn't it? Bending of light when light beam passes through from one medium to another. Then you will get what? After passing out of the prism, there will be splitting of light that happens. Okay, there will be splitting of light that happens, and here you can see VIB or color, VIB, GYOR. Okay, that 7 colors will be splitted. VIB, violet, indigo, blue, green, yellow, orange and red will be the splitting. And here the maximum deviation will be for the maximum deviation will be for the violet, isn't it? Maximum deviation for the violet, and violet has the least wavelength. And the minimum deviation will be for the red. Minimum deviation will be for the red color, and it is having what? The highest wavelength. Highest wavelength, or lambda we can write. When light passes through a prism, it splits into different colors. That is the VIB or colors. 7 colors it will be splitted, and here the maximum deviation will be for the violet color because it has what? The highest, the lowest wavelength. Okay, highest deviation for the least wavelength color, that is the violet, and maximum deviation will be for the red color, that is having minimal deviation for the red color, that is having the highest lambda. Maximum deviation for violet with the least wavelength, and minimal deviation is for the red color, that is having highest wavelength or lambda. Okay, there are mainly 2 types of spectrum, that is emission spectrum and also absorption spectrum. Emission spectrum and absorption spectrum. Emission and absorption. Okay, when we pass an excited radiation, okay, when electron is passed from the lowest energy level to the highest energy level, we usually call it as excited electrons. Or when excited electrons emit radiation and that radiation is passed through a prism, we will obtain what? In a black, we will obtain a spectrum like in a black background. We will have what? Bright colors. Bright colors will be there in the black background. We will obtain bright bands or bright lines in a black background. Bright lines in black background. And they are called as the emission spectrum. Okay, when the excited radiations are passed through a prism, we will obtain there occurs a splitting of light. We will obtain a spectrum, and in that it will be what? In a black background, there will be bright lines. Imagine that in a black background there will be bright lines, and that spectrum is called as emission spectrum. Okay, they will be called as emission spectrum. And that emission spectrum will be a characteristic peculiarity, will be having a characteristic peculiarity of that atom. So they are known as what? Fingerprint spectrum. We will call it as what? Fingerprint spectrum, because it will be what? Different for different atoms, like a fingerprint of a person. They will be different for different atoms. That is the emission spectrum. Similarly, we have absorption spectrum. That is the normal light when, or normal sunlight or normal light is passed, we will obtain a spectrum, and that will be like inside a continuous spectrum. Okay, there will be continuous spectrum of 5G or white light. When it is splitted, we will obtain what? A continuous spectrum. Inside that continuous spectrum, if there is what? Lines, or if there is bright lines inside a continuous spectrum, that is called an absorption spectrum. So we studied about two spectrum, emission spectrum. Emission spectrum is important, and also we studied about what? Absorption spectrum. Emission spectrum, there will be in a black background, we will obtain bright lines. So the points are, emission spectrum is obtained by passing radiations that are emitted by excited atoms through a prism. Okay, excited atoms or excited radiations of atoms, if we are passing through a prism, then we will obtain what? Emission spectrum. And it consists of bright lines against a black background. And that spectrum is a characteristic of the electronic environment of atoms. So they are called as fingerprint of atoms, or we will call them fingerprint spectrums. That is, they are the characteristic of electronic environment of that atom. Okay, so called as fingerprint of atoms. Absorption spectrum is obtained by analyzing solar light emerging out of a solution of a substance and dark lines of bands in a continuous spectrum is the result of absorption spectrum. Okay, we will obtain dark lines of bands in a continuous spectrum. Note both the points regarding absorption spectra and emission spectra. We already studied about electromagnetic radiations. This is just a recap. Electromagnetic spectrum it's a pattern of arrangement of different type of electromagnetic radiation. Electromagnetic radiation and its characteristics like wavelength, frequency, we already studied. Spectrum obtained from an electromagnetic radiation is called electromagnetic spectrum. That is, it's a pattern of arrangement of different type of radiations in order of increasing wavelength or in decreasing frequency. The order of increasing wavelength or decreasing frequencies, that is, they are inversely proportional. C is equal to nu lambda we studied, isn't it? Nu lambda. C is equal to nu lambda. That is, nu frequency is equal to C by lambda. That is, nu is inversely proportional to what? Lambda, or nu proportional to 1 by lambda. Okay, when frequency increases, wavelength decreases. That is, this order is in the increasing wavelength or decreasing frequency. The lowest wavelength is what? Cosmic rays. Then comes gamma rays, X-rays, UV, ultraviolet, UV visible rays, then IR rays, microwave region, and also the radio waves. This is the order of increasing wavelength or what? Decreasing frequencies. That is, cosmic rays is having the highest frequency. In the visible region, it goes in the order VIBGYOR, we studied. Red has the highest wavelength and violet has what? The lowest wavelength. Next, about an important term, that is line spectra or line spectrum. Elements usually give what? Line spectra. It's a characteristic. Okay, line spectra is a characteristic of the excited atoms that are producing it. Okay, from the line spectrum we can obtain which is the atoms that are producing it. That is, it's a characteristic of the excited atoms producing it. No two elements will have what? Identical line spectra. Every spectra will be the characteristic property of that atom or that element. Okay, no two atoms or no two elements will have identical line spectras. Next point is an important point. The line spectra that is resulting from the emission of radiations from atoms of elements. The line spectra that we are obtaining from the emission of radiations from the atoms is called as what? Atomic spectrum. Emission of radiation from atoms will result in a spectra, that is a line spectra, and we call it as atomic spectrum. Similarly, when radiations are from a molecules, okay, we will obtain what? A band spectra. From an atom we will obtain the emission of radiation from an atom, we will obtain what? A line spectra, and that is called as atomic spectrum. Similarly, the emission of radiations from a molecule will give you a band spectra, not line spectra. From a molecule will give you a band spectra, and that is called as molecular spectrum. Okay, radiations from molecules will give you band spectra, and that is called as what? Molecular spectrum. Okay, this much information is regarding what? The spectra, about line spectra, molecular spectra, atomic spectra we discussed, and also the increasing wavelength or the decreasing frequency of electromagnetic radiations we discussed.